Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation on DTC P0138, which stands for Secondary Heated Oxygen Sensor, HO2S Circuit High Voltage, specifically for the Honda CRV models from 2017 to 2022. This error indicates that the secondary HO2S, also known as sensor 2, is sending a voltage signal that exceeds the normal operating range, which can lead to incorrect fuel mixture adjustments and affect engine performance. The secondary HO2S is crucial because it monitors the efficiency of the catalytic converter by evaluating the exhaust gases coming out of it. Typically, this sensor is located in the exhaust system after the catalytic converter and is essential in helping the engine control module, ECM, manage emissions and optimize fuel efficiency. Addressing this DTC promptly is important to ensure the vehicle runs smoothly and adheres to emission standards. This presentation will give you a step-by-step guide to troubleshooting this error efficiently. DTC P0138 indicates an issue with the secondary heated oxygen sensor, commonly referred to as HO2S, observed in Honda CRV vehicles. This component is critical for assessing the exhaust quality and ensures that the catalytic converter is functioning correctly. It is primarily positioned in the exhaust system after the catalytic converter. Its role is to send feedback to the engine control module, or ECM, about the oxygen levels in the exhaust stream. A high voltage signal from this sensor can indicate that it is malfunctioning, either due to wiring issues, an open circuit, or sensor failure. Diagnosing this error involves monitoring the voltage levels through special diagnostic tools like the Honda Diagnostic System, abbreviated as HDS. Understanding the location and function of the secondary HO2S is essential for accurately identifying potential faults. The possible causes for DTC P0138 primarily include a faulty secondary HO2S sensor, problems within its wiring, or poor electrical connections. A malfunctioning sensor may produce erratic voltage readings that exceed 1.27 volts, indicating a high voltage situation. Wiring issues can stem from fraying, corrosion, or accidental disconnections, which can obstruct signal transmission from the sensor to the ECM. Additionally, any loose terminals can lead to intermittent failures that complicate diagnostics. It's important to examine these possible causes thoroughly to avoid unnecessary replacements. Ultimately, isolating the origin of the issue allows for targeted repairs and ensures efficient vehicle performance and compliance with emissions regulations. When experiencing DTC P0138, you might observe several symptoms that can significantly affect your vehicle's performance. One of the most common symptoms is the illumination of the check engine light, which serves as a notification from the engine control system, indicating a fault that needs addressing. Additionally, you might notice a drop in fuel economy, as the malfunctioning secondary HO2S can lead to incorrect fuel mixture adjustments. This inefficiency can pressure the engine, resulting in rough idling or inconsistent acceleration. Furthermore, you may also experience stalling or other erratic driving behaviors that compromise safety and comfort. Monitoring these symptoms can not only help diagnose the problem, but also prevent further complications down the line. In the first troubleshooting step for DTC P0138, begin by turning the vehicle ignition to the on position without starting the engine. This prepares the vehicle systems for diagnostics. Next, clear the DTC using the Honda Diagnostic System, or HDS, to reset any existing fault codes stored in the engine control module's memory. After this, switch the vehicle to the off mode. Then start the engine and let it idle until the radiator fan engages. This step allows the engine to reach its normal operating conditions before taking any measurements. Once these conditions are set, you will proceed to check the voltage readings from the secondary HO2S. It's crucial to monitor for any abnormal values exceeding the 1.27 volts threshold specified in diagnostics. For the second troubleshooting step, you will start by turning the vehicle's ignition back to the off position. Next, disconnect the 4-pin connector from the secondary HO2S to gain access for further testing. This disconnection is vital for isolating the sensor's functionality. Then, you will connect terminals A and B of the 4P connector using a jumper wire. The specific terminals being connected will allow you to create a direct path for testing the circuit. After setting the jump, turn the vehicle to the on position and again check the voltage levels from the secondary HO2S with the HDS. If the readings still exceed 1.27 volts, proceed to the next step. If not, replacing the secondary HO2S may be necessary, as it suggests a sensor failure. In the third step of troubleshooting DTC P0138, start again by turning the vehicle's ignition to the off position. This ensures that any adjustments made in the previous steps do not interfere with the tests that you are about to perform. Next, remove the jumper wire from the secondary HO2S 4P connector and replace it accordingly to prepare it for further testing. Then, you will set up a new jumper wire connection between terminal A of the secondary HO2S connector and body ground. With the circuit reconfigured, turn the vehicle to the on mode once again. You will now check for the same voltage output using the HDS. An appropriate voltage level aligned with the specifications confirms that the SO2SG wire is in good condition. If this condition persists, you will advance to the next step for further checks. The fourth step involves further assessment of the SO2 wire for continuity. Start by ensuring the vehicle is in the off position once more. Next, jump the SCS line using the HDS to create a short circuit. This condition must remain for more than 1 minute. Following this setup, disconnect the PCM connector A, which consists of 50 pins, to perform a continuity test. Now, check for continuity between designated test points. Here, you will check points 1 and 2. Point 1 corresponds to the PCM connector A, pin 47, while point 2 will be the body ground. Successful continuity indicates that the SO2 wire is functioning correctly, thereby indicating no issues in the wiring to and from the secondary HO2S. If no continuity is present, it is essential to repair an open circuit in the SO2 wire leading from the PCM to the secondary HO2S. In the final troubleshooting step, you will execute checks on the SO2SG/SO2SG wire for continuity, which is vital for a comprehensive diagnosis. Again, start with the vehicle in the off position. Remove the previous jumper wire connection from the secondary HO2S 4P connector and install a new jumper wire from terminal B, which is pin 2 of the secondary HO2S, to body ground. As before, utilize the HDS to jump the SCS line and allow a minimum of 1 minute for this condition. After setup, disconnect the PCM connector A to test for continuity. You'll assess the continuity from the PCM connector A, pin 48, to the body ground. Affirmative continuity confirms that the SO2SG/SO2SG wire is functioning properly. If there is no continuity, you will need to repair an open circuit in the associated wire running from the PCM to the secondary HO2S, ensuring effective monitoring of exhaust gases. Finally, after completing all the necessary repairs associated with DTC P0138, it is crucial to verify the success of the repairs. Begin by confirming that all identified issues, be they sensor replacements, wiring repairs, or connection checks, have been duly completed. Once confirmed, clear the DTC using the HDS to reset the engine control system. This action provides a clean slate to ensure no residual fault codes remain. Following that, it is highly recommended to conduct a test drive under varied conditions to assess the vehicle's equilibrium and performance. Observing that the check engine light remains off and no new codes are triggered is the ultimate goal of this verification process. Should everything function as expected, you can be confident that the repair has been successful. While this presentation emphasized troubleshooting DTC P0138, it's important to integrate preventive maintenance strategies to minimize future occurrences. Regularly inspecting electrical connectors and wiring associated with the secondary HO2S can help avoid potential faults caused by corrosion or physical damage. Additionally, maintaining the integrity of the exhaust system is critical, as leaks can lead to inaccurate sensor readings. Scheduling periodic checks for all oxygen sensors and their associated circuits will help in early detection of issues, allowing for timely interventions before they escalate into more significant problems. Keeping a close watch on these components contributes to better vehicle performance and longevity. By implementing these practices, you can significantly reduce the chances of running into this DTC again. In conclusion, DTC P0138 signifies an issue with the secondary HO2S circuit high voltage in Honda CRV models from 2017 to 2022, impacting emissions and engine efficiency. Through comprehensive troubleshooting steps, we have highlighted the importance of addressing wiring, connections, and sensor functionality. Identifying the root cause is crucial, whether it's a faulty sensor, open circuits, or poor connections. Furthermore, adopting preventive maintenance habits will not only enhance sensor reliability, but also contribute to overall vehicle performance and longevity. By following these diagnostic and repair procedures, you can effectively resolve DTC P0138 and ensure compliance with stringent emission standards, thereby maintaining a well-functioning and environmentally friendly vehicle. Please like and subscribe to the channel. See you next time.